Very good afternoon, respected juries and ladies and gentlemen. My name is Ram Prakash Holla. I represent Distinct Productivity Solutions. Before I start, I want to tell a fact. I have been a follower of this Productivity Summit for last 3 years, and all along I had a crib that, this event is a corporate's event, and the SME has no place here. So this was a crib with me, and in the last year's summit, I recall Sri Dhand Sir's in his closing session, he said, every corporate should bring in one SME to this summit, and probably due to such visionary thoughts of the IMTMA leaders, probably I'm here representing the SME case study. I'm very happy and proud to represent the whole SME community of the nation. So, going forward, let me start my presentation, case study. So, I want to introduce my company. I would like to call it as a setting the stage, because right from morning we've been hearing, 20,000 crores, 10,000 crores and all big figures. So we are a small company with about 24 crores turnover, and it's founded in 2004 by myself and my partner. So, after working for about 10 years each in leading machine tool companies of India. And now we are Tier 1 precision component manufacturers for a couple of OEMs. And we have an integrated facility of die casting, and we supply components to mobile hydraulics, automotive and material handling sectors. We export about 30% of our components to US, Canada and Italy. We believe that we have survived in this market due to our productivity approach. Because the kind of prices we get, only productivity can allow us to survive. So these are some of the components what we manufacture, supply, export, and these are few of our customers. Well, coming to the case study, this is a productivity approach for price-sensitive critical component manufacturing. So this component, what I'm talking about, the object of the case study is a component which is required in high volume and low variety. It's an aluminum component. It's a critical component with very high accuracies. This goes to hydraulic gear pumps. So it required very high accuracies and requires in high volume. So it was, when we started this, it was an import substitution. It was happening in Brazil and Germany and UK. So just to get a feel of it, this is the component, what I'm talking about. And the need. So the very interesting fact about this component is this is required about 8 million pieces per annum. So for Indian requirement is about 2 million pieces. So as of now, we are very successful to supply these 2 million pieces to Indian requirement. And our objective was to expand, because the same component is used in Germany and Germany and Brazil. So objective, we wanted to produce this component in a most productive possible way. So let's go on to the current method. We started this originally in 2013. So, at that time, this was the line. This was the line we had. So, OP10, OP20, 30 and 40, the 4 operations. And we had done, there's a line imbalance. The balancing was done by adding the OP32 machines. So cycle time, my TAC was 17 seconds. So we should tell something about this OP30, which is the focus area of this case study. So OP30 was a machine which is a semi-CNC and CAM operated. It was dedicated, it was not flexible, it was an operator dependent. Here we see one, there is one stopper which would come every time for every cycle in between. For that, the operator would press a foot pedal or a cycle start, and this was adding. So what we saw, the operator at the end of a 12-hour shift would have pressed the foot pedal for 2,400 times. It's a huge fatigue factor. So, but at the same time, it was very good on accuracies. It was controlling more than 27 teardrop dimensions in this particular operation. So everything was good till 2015, like, we were supplying, we had established good quality, cost, deliveries, and all these things. Because of that, the quantities jumped suddenly from 4,000 pieces per day to 8,000 pieces, because customer wanted to localize these components, and also the market grew and cost pressure was phenomenal on this. So this was the time we wanted to, it was a good opportunity for us to take it forward. So here, during this period, we had done a lot of continual improvements, kaizens and all that, but when the jump was sudden, we felt that this may not support. We will have to go for an innovative solution. This was an invitation to innovation. So as I said, we had two options: to repeat, to duplicate the existing line and go ahead with whatever established methods. We had option 2 to focus, because we didn't had much problems on these OP10, 20 and 30, but we wanted to focus more on the OP30 area. We subjected this operation, this machine, the whole machining system, to various analysis. See, what we observed in the machine, about 47% of the time was used for loading, unloading, and the stopper coming in, going back, and these kind of things. This was required for to achieve the required accuracies. The cutting time was only 53 seconds. Of course, cutting time adds all these XYZ movements all. So this was one big area of improvement which we wanted to address. And also we observed that the labor cost would have been 27% of the total conversion cost if we duplicate the machine, because we would require 8 operators only for this operation. So we are an SME, we operate on 12-hour shift generally, and the huge fatigue factors will add. So as I said, the operator would press the foot pedal for 2,400 times in a 12-hour shift. It was operator started feeling that it's an punishment area if they have to work on this. Of course, the space consumption would have been 990 square feet if we duplicate, and power consumption was also more. So with all these considerations, we derived at the specifications of the desired new method. We wanted a fully flexible CNC machine. We wanted one machine which could produce 9,600 pieces per day, and this idle time we wanted to completely eliminate and use less space, less power, and possibly use unskilled operator and run the show. So, okay, this was just a breakup of how we did the analysis of cutting time and the idle time. So it's 47% versus 53. So when the quantities jumped from 4,000 to 8,000, the new tack was 9.5 seconds. And the shift output required was 4,800, and the day output required was 9,600. My machine, whatever we want, should have a capacity rather to produce 9,000 pieces per day. So we would require 4 machines to reach this quantity. So we derived certain inferences out of this. So probably in whole of my case study, these 2 sentences are the, I would say the essence of the whole case. So the current cutting time was 17 seconds. It dropped tack is 9.5 seconds. It meant that 2 spindles should work at a time. And the idle time, we didn't want to take any idle time. This meant that the working spindle should only work. It should not do anything. It should not be used for any loading, unloading. Precisely, I would say we wanted to mask the loading, unloading. But these are turning operations, so masking in turning was a question. So this is how, this is what is the line diagram of say 4 machines. If we had gone with all the 4 machines and 4 operators, 4 CNC systems, and so on and so forth. So when we decided that, we had decided that the 2 spindles should work operating, and this should be only operating. It should not be used for loading and unloading. So the other side, the 2 spindles can be used for loading and unloading. So that is what is the combination. So by doing this, these 2 slides were not required. Okay? So the revised configuration looked like this. The tools could be mounted onto the same slide on the left and right, and because when the loading unloading is happening here, these tools have no work. This same slide can go on the other side and finish its work. It can, when it finishes, this side can be used for loading, unloading, and the other side can be used for operation. So this eliminated 2 more CNC systems and 2 more operators, and the whole system would have looked like this. So, but the cutting time is only 17 seconds, and in this 17 seconds, the operator would have done the loading, unloading here, and he should also look after the cycle, operation of the component. So this we felt is already with 32 seconds, we had a huge fatigue factor for the operators, and then we felt that this is too small a time for the operator efficiency to look at. So that is when we thought that this is the system which is suitable for robotic implementation. So robots do not come alone, they come with all these infeeders, outfeeders and all that. So we would have reduced the whole system with just one operator who would do the component loading onto the conveyor. So this is the overall configuration derived for the machine. So this was precisely looking like a pallet changer concept in a turning center. A robot was planned for loading and unloading. It is fully CNC controlled, and to increase the reliability, all standard elements of a CNC turning centers were used. It was like some 4 turning centers on a single base, something like that. So when we made it, the whole system looked like this. So at this point of time, I would like to, I want to remember the machine tool builder, who was an SPM builder, who built this whole machine. And so as I explained, see, we have 2 spindles here, which are the working spindles, and 2 spindles here, which are used for loading, unloading alternatively. So when this spindle is working, the other would not work. When the other spindle is working, the other one will help. So we'll just see a small video on this. So now you can see the machining is going on in this area, and the loading unloading is happening on the other side. By the way, we had 2 varieties here, LH and RH. So the first 4 components on the slats conveyor is loading LH components, and the other side it would load the RH component. Here also we have, the partition. Well, so this is what was established in 2015-16, and yes, the whole journey was establishing of this was not as smooth as what I explained or narrated. So we did had quite a few challenges. If you see the whole system, we have three things here: the robots and the machine and the peripherals. So if I put it in the scale of technology and reliability, the robots are at a very high reliable items. Robo we had bought from a world leader, but like all other entrepreneurs, we also did a mistake, like getting the global robot and using a local end effector. So this end effector reliability makes a lot of sense to balance the overall reliability of the system. When it came to the machine, all standard elements of the machines of a turning center were used. Could be LM guides, could be ball screws, could be checking cylinders, could be. These machines, by the way, had the glass scales on both the axes to control the accuracies. For us, it was a standard machine, but for its configuration. The real worry was in this area of peripherals. So very few reliable sources. The highest contributor to lower the overall system's reliability. Integration is not very smooth. So it's very essential to bring the reliability of the peripherals to the tune of the machine, if not to the tune of robot. So this is something, if I see my breakdown register of last 3 years, the major breakdowns are coming from the peripheral side. Whereas the robots and machine side, there have been very few breakdowns. So we learned a lot of lessons. The reliability of the whole system is very important, including the in-feed component. Because when it is a manual system, we don't care about the in-feed system, in-feed component, little bit bursts here and there and all, the man can adjust. But the robo cannot understand all that. It has to be understandable to the robo. Robot grouting is a must. Like, we are tuned generally to place the CNC machine, level it and start using it. So with that knowledge, we try to go with the similar system for robo, which is wrong. Because of the huge inertia movement, we will require robo grouting. So global robots and local end effector, we have to invest on a good amount of accuracy into the end effectors. This was very interesting. The robo teaching was much easier than CNC programming. CNC programming learning was rather difficult. So we had a lot of intangible benefits of such a high-tech system. Intangible in the sense, we talked about a lot of culture building to the people and all these things. So what I observed here was that we could anyway shift the skill to the machine. We were able to shift some amount of cultural changes also to the machine. So by bringing in this system, because in an SME, it's very difficult to hire very good people and retain very good people and train them, and these kind of challenges we have. So what I felt, this was something intangible I felt, that we had shifted some cultural issues to the machine, wherein the machine is taking care of that. By virtue of that, the operator's culture also would improve. So this is something we felt, and it demonstrates a high amount of commitment to my customer. So to withdraw the existing systems in a phased manner, and the return on investment was not very high. Generally, we have a myth saying that it is 8 to 10 years, but it was not so. It was 3 to 4 years. So this is what we finally worked out. there was an overall cost benefit of 43% saving, and the major savings coming from the labor cost, because we had reduced from 8 to 12, 8 to 2. So this is how we produced, the volumes have gone. Now, as of now, we are supplying 2 lakh pieces per month to the customer. The conclusions, we had registered a cost reduction of 43%. So here I would like to mention, it was very coincidental that 47% of the idle time was converted into productive, and time is money. We have registered, somewhere it is a coincidental, 47 to 43%. So customer is satisfied with 2,000 pieces per month. So we have registered a growth of 30% in the last 3 years, and we've also signed a business contract with this customer for next 3 years with giving 3% cost reduction. So the thought process has changed. We have got a feel of it now. Using a high-tech system, we have got a feel of it, we have got a hang of it. We want to go ahead in this direction. And definitely it was a good technological leap for a SME company like us. So this is all I have. Thank you very much.